Okay, let's discuss about projectile motion. So, projectile motion. Fine. So, what is projectile motion? First thing is, okay, let's see. So, let's say you throw an object with a velocity v at an angle theta with the horizontal, and it lands up here. Correct? Now, this kind of motion is called projectile motion. You're projecting something. Okay, now how to analyze this kind of motion when it is going on a curved path? So the first thing that we have to remember in this is the projectile motion is combination of uniform motion in horizontal direction and accelerated motion in vertical direction. Accelerated motion in vertical. Correct? So that means that we can analyze projectile motion in terms of these two. Correct? Now let's see how do we do that. So when you have thrown an object with a velocity v, so the velocity which is at theta degree angle with the horizontal, it has a horizontal component which we can call as v cos theta and a vertical component v sin theta. Correct? Sum of two vectors is this one. Correct? So sum of, let us say, vx and vy is v, vector addition. Reverse of that is the resolving. So saying that an object which is thrown at velocity v at an angle theta with the horizontal can also be said to be thrown with v cos theta horizontal velocity and v sin theta vertical velocity. So instead of this velocity v at an angle theta, we can have two velocities, vertical and horizontal. Fine. So let's say you throw an object with this velocity. Now, once the object is out of your hand, you have thrown it like this. It's out of your hand. Now the only force is gravity force. This is the force. So we have these two velocities and this is the force. Now if you neglect the air resistance, that means there's no horizontal force on the body, which basically means if there's no horizontal force on the body, the horizontal velocity will remain constant. That means horizontal velocity throughout the journey will be v cos theta only. What will this force do? This cannot change horizontal velocity because this is vertical force. It will change vertical velocity. Correct? So that means this force will cause first deceleration and then acceleration with this velocity, and it will not change this velocity. Correct? So since this velocity remains constant, that's why I have said it's uniform motion in horizontal direction. Uniform motion means the speed remains constant, and when the speed remains constant, the equation that we use is distance is speed into time. Yeah, s is speed into time. So let's say horizontal distance traveled in this case is speed v cos theta into time of flight, right? And what about the vertical motion? For vertical motion, we have equations of motion under acceleration. Correct? So s is equal to ut plus half at square. Now we are applying this equation for the vertical part of the motion. So u is the initial vertical velocity. Correct? S is the vertical displacement in time t. Fine. And if you want to calculate velocity, vertical velocity at certain point of time, you can use v is equal to u plus at.